بسم الله الرحمن الرحيم. Bismillah ar-Rahman ar-Rahim. We will record today important section in Math 2, which is trigonometric functions of any angles. In this section, we will consider angles in standard position. Standard position. And we will consider a point B of xy on a terminal side of any angle, which means we will go not only in the first quadrant where we have here theta, the terminal is in the first quadrant, here we call it y, this is x, that's r. The terminal could be in any angle, could be this one, or any other quadrant. So the first thing we need to discuss is how to define our trigonometric functions. Our trigonometric function sine theta will be y divided by r. Cosine theta is x divided by r, and tan theta is y divided by x. Of course, cosecant will be r over y, secant will be r over x, and cotangent will be x over y. So these are the basic definitions which must be well written in our brain like our name. Now, if we consider the trigonometric function, when we say sine theta, it's y over r, means when sine is positive, y will be positive. So whenever you have y positive, that means sine theta and cosecant theta is positive. Whenever we have cosine theta is equal to x over r, means whenever we have x positive, we will have cosine theta is positive. That's why we have a new idea, which is STC, which means, of course, here all the trigonometric functions are positive. Here only sine and its reciprocal is positive. And in quadrant number 3, only tan and its reciprocal is positive. And the quadrant number 4, it's only cosine and its reciprocal is positive. And we get it actually from these two ideas. So this is just a summary. All the trigonometric functions are positive in the first quadrant. Sorry for this. And in the second quadrant, we have only sine. In the third quadrant, we have only tan and its reciprocal. And in the fourth is, as I said, STC. Here is all are positive. Now, let's start with a basic question. Here he gave me the terminal side passing through the point -3 and 5. So all what I need to do, go and sketch the point. Where is -3 and 5? So this is -1, -2, -3. 1, 2, 3, 4, 5. So that will be the point. So we have always, we start from the origin, going to the terminal point, and we close it with the x-axis. Remember, we close the triangle with the x-axis. So I have this is equal to -3, and that is equal to 5. I need to find what is r from Pythagorean theorem. We have x squared plus y squared equal to r squared. So I will have 9 plus 25 is equal to r squared, and this means r will be square root of 34. Always r is positive. Remember, always we have a common sense. X direction here is positive. X direction to here, it's negative. Upward, y direction is positive, and downward, y direction is negative. So he need the 6 trigonometric functions. So basically it's sine theta, which is y divided by r. So y is 5, r is square root of 34, which can be written as 5 square root of 34 over 35, over 34 when we multiply by the conjugate. Of course, once we find sine, means we find the cosecant theta, which is r over y, which is square root of 34 divided by 5. Cosine theta, it's x over r. So our x is -3, our r is square root of 34. Again, if we multiply it by the conjugate, we will say -3 square root of 34 divided by 34. Once we find cosine, means we found secant, which is reciprocal upside down. So it will be -√34 over 3. Number 5, it's tan, and tan it's defined by y over x. Y is 5 over x minus 3, but remember that can be written as -5 over 3 as well. And the last one, it's cotangent theta, which is x over y, and that is -3 over 5, which is upside down of tan. Now, here is another question. He said find the values of the 6 trigonometric functions if we have the terminal side passing through the point 0 and 2. If we graph this one, this is the xy coordinate system. I have the point 0 and 2. That's the point 0 and 2. So basically our terminal side here. So our angle is actually what? It's the 90 degrees. Here we have y is equal to r is equal to +2. And our x is equal to what? 0. So we have the solution now. Sine theta, it's y over r, which will be 2 divided by 2, which is 1. Cosecant theta, it's y over y, which is again 2 over 2, which will be again 1. Cosine theta, it's x over r, which is 0 divided by 2, which is equal to 0. And secant theta, it will be undefined, because we cannot have 2 over 0. Or we could say it's infinity, undefined or infinity. Number 5, we have tan theta, which is equal to y over x. Y is equal to what? 2. X is 0. Again, that is undefined. In calculus, we call it infinity. Cotangent theta, it's the reciprocal x over y, which is 0 over 2, which will be again 0. These are the 6 values of the trigonometric functions. Remember, we call these quadrantal angles. The 0 angle, 90 degrees, 180, and 270. We call them quadrantal angles, which usually we get it actually from the unit circle, and that's what we did in section 5.5. 1, 0, 0, 1, minus 1, 0, 0, and minus 1, and we said cosine always related to x, and y, it's always equal to sine, because our radius here is equal to 1. Now, the next example, we need to evaluate some quadrantal angles like tan 180. I said the easiest way to do that one is using the quadrantal, using the unit circle and the quadrantal angle. This is 0, that's 90, 180, 270. And remember the point in the unit circle, this is 1, 0. That is 0 and 1, minus 1, 0, 0 and minus 1. So if you speak about tan 180, that is actually y over x, and 180, this is x, that's y. So it will be y is 0 over x is minus 1, so it will be 0. Now, the next question, he said, what is 270? 270, again, if we look in the unit circle, which this has to be well written in our brain like our name. This is 0, 1. This is minus 1, 0. That's 0 and minus 1. This is, of course, the angle 270 degrees. So when we say cosine 270, this is x, that's y. So it will be cosine is x over r. And remember, if we say 270, r is equal to 1, so it will be x equal to 0, so that will be 0. Similarly, cotangent 90 degrees, using the unit circle again, this is 0 and 1. So cotangent, we could say it's cosine 90 over sine 90, and cosine is x, sine is 1, so that will be 0. Pi over 2, it's the same thing. Pi over 2, it's the same as 90 degrees. So that is 0 and 1, and that is actually the y coordinate, which is equal to 1. Cotangent 11 pi, it's actually cotangent 11 pi minus 5 revolutions, 5 times 2 pi. And that's a coterminal angle, so cotangent 11 pi, it's actually equal to cotangent 11 pi minus 10 pi, because 10 pi represent complete circles, so it will be cotangent of pi, and cotangent of pi is equal to what? We need to go to the unit circle and say this is minus 1 and 0. This is cosine pi, that is sine pi. So cotangent pi, it's cosine pi over sine pi, and cosine pi is -1. Sine pi is 0, so that will be actually minus infinity or undefined. We call it here in our course. Undefined in calculus, we call it minus infinity. Now we call it undefined. We call undefined because we are dividing by 0. Now let's go to the another form of testing the idea of trigonometric functions. Here we need to specify in which quadrant, and he gave me which quadrant. He said pi over 2 pi. So go 2 pi over 2 pi. Of course, you need to know this is 0. That's pi over 2. That is pi. That is 3 pi over 2. So the angle is between pi over 2 to pi, means our angle is a second quadrantal angle. So remember always, when you draw the triangle, you start from the origin, you go to the point, you close it with the x-axis, not with the y-axis. It must be with the x-axis. So your angle, that is your angle beta. From the origin, you go upward, you close it with the x-axis only. So when he gave me cosecant beta is equal to square root of 2, I should know sine beta is the reciprocal, which is 1 over square root of 2. And since we said sine, it's y over r, means y should be 1, r should be square root of 2, because that is equal to y over r. So we need to calculate x. Using Pythagorean theorem, x squared plus y squared is equal to r squared. So I will have x squared plus 2 equal to 1, which means, sorry, y is 1. So it will be 1 equals to 2. So x squared is equal to 1. So it's, again, we have x squared plus y squared equal to r squared. Your y is equal to 1. So 1 squared is 1. R is square root of 2. So when you square it, you get 2. Now, be careful here. When we say x squared equals to 1, our x must be -1. Why it's -1? Because we are in quadrant number 2. In quadrant number 2, the x is negative. So that should be equal to -1. Before you go to your calculations, always remind yourself to check the common sense direction. Here, x is positive. Here, x is negative. So we are at negative direction. So we say it must be -1. And this direction is positive and 1 is positive. Always r is positive. What he wants to find what is cotangent beta. Cotangent beta, it's actually cosine beta divided by sine beta, or you could say cotangent beta, it's x over y. It's either way. If you say x over y, so x is -1, y is equal to 1. So what you will get is -1. And of course, that is matching with our direction STC, because STC will say here only sine is positive and cotangent, definitely it is negative. Now, continuing the same idea. Here I need also to specify in which quadrant first. I have tan is positive. Where do we have tan is positive? Remember STC. So when we say tan is equal to 1 means positive. Where do we have tan positive? We have it in quadrant 1, and we have it in quadrant number 3. That's the first condition. Tan is positive. Where is sine is positive? Sine is positive in quadrant number 1 and in quadrant number 2. Now, where do we see both are satisfying both conditions, it must be in quadrant number 1, where we have the 2 ticks. So our then angle should be in quadrant number 1. In quadrant number 1, when we draw the triangle, this is our angle theta. It says tan theta is equal to 1 and sine theta is equal to square root of 2 over 2. If we consider sine theta, that means this is equal to y over r. Y is equal to root 2. And r is equal to 2. So we need what is x. Again, Pythagorean theorem will say x squared plus y squared equal to r squared. This means x squared plus y squared, it will be 2. R squared is 4, so we have x squared equal to 2, x equal to plus root 2. Why we say plus root 2? Because in quadrant number 1, x is positive. So that must be root 2. Of course, that's coincide with this one, because tan is y over x and root 2 over root 2 is 1. But he want what? He want what is secant. So to find secant, we will find first cosine. Cosine theta, it's x over r. So x is equal to root 2 over r, which is 2. So if I want to find secant, it's 1 over cosine theta, or upside down. So it will be 2 over root 2, or it's 2 root 2 over root 2 times root 2, which is 2 root 2 over 2, which is equal to square root of 2. That's one way to do it. Another way, method 2, we could say if I have tan theta is by rule equal to sine theta divided by cosine theta. This means I have here tan theta is equal to 1 is given. And I have here sine theta is equal to root 2 over 2 is given, and that's cosine theta. So that will mean I could say cosine theta is equal to root 2 over 2 by multiplying, that's 1 over 1, cross product. That will mean secant theta, it's 2 over root 2, which is equal to root 2. Either method is okay to solve this question. Now, here it says find the exact value of cosine theta if we have tan theta is 1 and sine theta is negative. First of all, we need to specify in which quadrant we are working. It says tan theta is equal to 1. Where do we see tan positive? Tan positive in quadrant 1 and in a quadrant number 3, STC. Sine is negative. Sine is negative. It will be in a quadrant 2 and in a quadrant number 4. Where do we see 2 ticks? Here. So it means we are in quadrant number 3. So we draw the triangle, as I said, from the origin. We go downward, we close it with x-axis. Here it's given to me tan theta is equal to 1. Means this is x over y. So this means that's 1 over 1. So x will be what? Many of you will say x here is 1, y is 1. But that is completely wrong. Why it's wrong? Because this direction for x is what? -1. This direction for y is what? It's -1. Now, we need to calculate r. X squared plus y squared equal to r squared. So that will be 1 plus 1 is equal to r squared. R always positive, so r will be square root of 2. Now, what he wants? Cosine theta. Cosine theta, it is x over r, and our x is -1, our r is square root of 2. Be careful about the direction, the sign direction. Here is x negative, here is x positive. Why? Upward positive y, downward negative y. That's basics. Common sense direction. Now, similarly, we have here what's given to me. Given secant theta is equal to -4 over 3. That will mean cosine theta, it's the reciprocal, -3 over 4. And it says tan theta is positive. Again, we need to specify in which quadrant. When he say tan theta is positive, STC. Tan is positive in quadrant 1 and the quadrant number 3. Cosine is negative. Cosine is negative in quadrant number 2 and the quadrant number 3. So we have 2 ticks, means we must be in quadrant number 3. So what is given here? Cosine theta is -3 over 4, means this will be x, that is r. X is -3, r is 4. We need what is y. Before we go to that one, we check our common sense. X direction is negative, and that's negative. Now, this direction for y is what? Negative. So when we apply Pythagorean theorem, x squared plus y squared equal to r squared, x squared is 9 plus y squared, we need it. R squared is 16. So y squared is equal to 7. Y will be what now? Negative root 7. Why negative root 7? Because this direction for y is negative. So y will be negative root 7. So y is equal to negative root 7. Now, we come to answer his question. He wants sine theta. Sine theta is equal to y over r. Y is minus root 7 over r, which is 4. That's one method. What's the other method? We just said method 2. We know when we have secant theta is equal to -4 over 3, that will mean cosine theta, it's -3 over 4. We have identity says sine squared theta plus cosine squared theta is equal to 1. So that will mean sine squared theta plus cosine squared, which will be 9 over 4 equal to 1. That will mean sine squared of theta is equal to 1 minus 9 over 4. Sorry, it should be 9 over 16. It should be 9 over 16. So that will mean sine squared of theta is 7 over 16, which means now sine theta, in which quadrant we are? quadrant 3 means sign is negative. So it will be minus root 7 over 4 because only tan is positive in quadrant number 3. That's another method which is using the identity sine squared plus cosine squared equal to 1. Now, for a non-quadrantal angle, we need to speak about now one of the most important concepts, which is reference angle theorem. To speak about reference angle theorem, we need first to recognize what is the reference angle in each quadrant. Of course, quadrant number 1, the reference angle is the same angle. So we don't speak, actually we are referring all the angles to the first quadrant. If we are speaking about quadrant number 2, what is a reference angle first? The definition of reference angle is the angle that where the terminal side makes with the x-axis. So if this is my angle, theta, the reference angle is the angle between the terminal and the x-axis. If this is my angle, theta, the reference angle from the terminal with the x-axis, not with the y. It's always with the x-axis. And the next case, if this is my angle, theta, the reference will be is that between terminal and the x-axis. So to calculate the reference angle in each quadrant, in quadrant number 2, it will be 180 minus the angle. In quadrant 3, it will be the angle minus 180. It's the angle minus 180. And if we speak about fourth quadrant, it will be 360, which is the complete circle, minus the angle is the way to calculate the reference angle. Reference angle theorem says what? Reference angle theorem, it says, this is a summary of what we said. Reference angle theorem says the following. Sine the angle is equal to plus or minus the reference. Cosine is plus or minus the reference. Tan is plus or minus the reference. How do we decide? We decide from STC, which means only sine is positive in quadrant number 2. So if we are in quadrant number 2, we will say sine theta is equal to sine the reference. But cosine will be the negative of the reference. Tan is the negative of the reference. If we are in quadrant number 3, we will say tan is equal to tan the reference, but sine will be negative of sine, and so on. Let's practice this important idea. First example here, it says, example number 8, find the reference angle of 351. Of course, when we speak about reference angle, first we need our angle to be between 0 and 360. Then we speak about reference angle. 351, it's between 0 and 360. In which quadrant? We go to the x-axis, we say this is 0, that's 90 degrees. That's 180 degrees. That's 270 degrees. Of course, when we complete the circle, it will be 360. When we say 351, means it's more than 270 and definitely less than 360. So that is the angle 351. And our reference angle is this one. What's the reference angle? We will say reference angle is 360 minus 351, and the reference angle will become what? 10 minus 1, which is 9. So 9 degrees is the reference angle. Here it says find the measure of the reference angle. But what he is giving me it's negative angle. It's not between 0 and 360. So I should say first, minus 475 degrees is coterminal to, we add how many circles? We said minus 475. We add 2 circles, which is 2 times 360. So that will be 720 minus 475. And that will be what? 720 minus 475. 10 minus 5, it's 5. And 11 minus 7 is 4. And 6 minus 4, it's 2. To check, 5 plus 5 is 10. 5 plus 7 is 12. 3 plus 4 is 7. So that is equivalent to 245. Now, once we are between 0 and 360, we go to the XY coordinate. We say this is 0 degree. This is 90 degrees. That's 180 degrees and 270 degrees. Where is 245? It's more than 180, less than 270. So that is 245 degrees. So the reference angle is 245 minus 180. So 5 minus 0, it's 5. And 14 minus 8 is 6. So 65 is the reference angle. Again, to check, you would have to say 5 plus 5, it's 10. So it's 0. And 7 plus 4 is, so 245. We add it with 65. 5 plus 5 is 0. And that is 11. Is it? Have we done a mistake? So let's see. We have 245 degrees minus 180 degrees. 5 minus 0, it's 5. 14 minus 8 is 6. Okay, so that's true. So 5 plus 5 is 0. And then, sorry, 5 plus 5, it's 10. So it's 0. And 6 plus 4, it's 10 plus 1. Oh. Sorry, it's 65 plus 180. 5 plus 0, we are adding this. 5 plus 0, it's 5. And 6 plus 8, it's 14. So 1 plus 1, it's 2. So I'm doing actually the wrong direction of adding. Anyway, so it's 5 plus 0, it's 5. 6 plus 8 is 14. And 1 plus 1, it's 2. So that's definitely the reference angle theorem. Now, again, find the reference angle. As I said, do not convert from degree to radian, radian to degree. No, we don't need that one. We just need to know the two systems. This is 0, that's pi over 2, that's pi, that's 3 pi over 2. Where is 18 pi over 7? It's very easy. Just know which number smaller than 18 will cancel 7. And definitely that will be what? 14. So you should say 18. It's 14 plus 4. over 7. So that will be 2 pi. When we say 2 pi means 14 over 7 pi plus 4 over 7 pi. So that will be what? 14 over 7, it's 2 pi plus 4 pi over 7. As we said, that means 18 pi over 7 is coterminal to 4 pi over 7. So we don't care about 18. We should care about 4 pi over 7. Now, 4 pi over 7 in which quadrant? So first of all, we said we have to make it between 0 and 2 pi. 18 pi over 7, it's not from 0 to 2 pi, because we said 18 means 14 plus 4 over 7. 14 over 7, it's 2 pi, so it's coterminal to 4 pi over 7. Then we have to go and say, why this is not erasable? Okay, cut this one. Okay. So that's, as we said, 0, that's pi over 2. That is pi, and that is 3 pi over 2. So when I have 4 pi over 7, look here, Shabab, 4 pi over 7. We need to know in which quadrant. Definitely it is smaller than pi, because if we want to make it pi, we need to have 7 over 7. So it's smaller than pi. It's more than pi over 2. Why it's more than pi over 2? Because I will get pi over 2 if I have 3.5 pi over 7. That will be pi over 2. So I am in the second quadrant. So that will be 7, 4 pi over 7. What's the reference angle? Reference angle of 4 pi over 7 is pi minus 4 pi over 7. So that's 1. So 7 times 1 is 7. 7 times pi is 7 pi. And 1 times minus 4 pi minus 4 pi. So that will be 3 pi over 7. It's the reference angle. Again, I'm repeating. First of all, 18 pi over 7 is more than 2 pi. So we said, which number will cancel out 7? The number which cancel out 7 is 14. So we said that should be 2 pi plus 4 pi over 7. So we said 18 pi over 7 is coterminal to 4 pi over 7. Now we need to locate that one in which quadrant. I said it must be smaller than pi, because if it is pi, it will be 7 over 7. And it has to be more than pi over 2, because pi over 2 means 3.5 over 7. So we said this is our angle 4 pi over 7. So the reference angle is this one, which means it's pi minus 4 pi over 7, which we get 3 pi over 7. Now, once we get familiar with how to find the reference angle, we will use it now and use the reference angle theorem. These type of questions is definitely coming in the midterm exam. So let's see how to deal with this sort of questions. We need to locate each angle in which quadrant and what's the reference angle. And then we use STC to decide positive or negative. I have 3 angles, 225, 300, and 405. 225 between 0 and 360, so I need to find the reference. 300, again, it's between 0 and 300 and 360, so I need to find the reference 405 more than a 360, so I need to use coterminal angle. So the first question, or the first angle, it says here 225, and you should know that's more than 180, less than 270. So that is in quadrant number 3, 225. What's the reference? The reference is 225 minus 180, and that is 45. STC now will say you are speaking about sine, so the sine of 225, it's the negative of sine 45. We go to the second angle. The second angle we have 300, definitely more than 270 and less than 360. So that is the angle 300. What's the reference? The reference is this angle, which is equal to 60. So that will be 360 minus 300, which is 60 degrees. So regarding STC, what he gave me cosine, so I will say cosine 300. In the fourth quadrant, cosine is positive, so it will be plus cosine 60 degrees. The third angle, we said 405 is coterminal. Coterminal to 405 minus one complete circle. So it will be 45, which means now tan 405, it's the same as tan 45s. Once we analyze these, and we have to know the two famous triangles we had. If this is 30 degrees, this is 60 degrees, that's 2, that's 1, that's square root of 3. And 45, that's 1 square root of 2. So now we can go and solve our question. I have sine 225 degrees times cosine 300 degrees minus tan 405. So we will say this is a product. We said sine 225, it's the negative of sine 45. We said cosine 300, it's the same as cosine 60. We said tan 405, it's the same as tan 45. So I will have sine 45, which is root 2 over 2, or 1 over root 2 from the triangle here. Cosine 60, it's 1/2, 1 over adjacent over hypotenuse. Tan 45, it's 1. So I have minus root 2 over 4 minus 4 over 4. So that will be over 4. It will be minus root 2 minus 4. Now, we move to a similar question. Now we have again 3 angles. The first one 17 pi over 4. And we should say 17 pi over 4 is coterminal to which number will cancel out 4? Close smaller than 17, 16. So we will say 17 means 16 over 4 plus pi over 4. So that will cancel out because it's 4 pi. So it's coterminal to pi over 4, which means, in another word, cosine 17 pi over 4, it's the same as cosine pi over 4 because coterminal angle means we will go to the same point. Now, similarly, we have two ideas here. One of the easiest idea, if we speak about tan minus pi over 3, I said to you that's odd function, so take the minus outside, so it will be negative of tan pi over 3. So we finish from that one. 570 is coterminal to 570 minus 360. So that will be 0 minus 0 is 0. And 7 minus 6 is 1. 5 minus 3 is 10. So 210 in which quadrant? It's more than 180, less than 270. So definitely that's 210. So the reference angle, its reference is 210 minus 180, which is equal to 30 degrees. STC will say you are speaking about cosecant, which is like sine. So cosecant of 210, it's the negative of cosecant 30 degrees. So we go to answer our question now. Cosine 17 pi over 4 plus tan minus pi over 3 minus cosecant 570, that is equal to cosine pi over 4, as we said, because it's coterminal. This negative will go outside, so it will be negative of tan pi over 3. Now, minus cosecant, we said it's coterminal first to 210. Then we said that is cosine pi over 4 minus tan pi over 3, that one. Pi over 3. Now we said cosecant 210, it's negative of cosecant 30, so that will be negative of negative will be plus cosecant 30 degrees. Now we need the two famous triangles, which has to be written in our brain like our name. This is 30 degrees, that is 60 degrees, 2, 1 square root of 3, 45, 45, 1, 1 square root of 2. Cosine pi over 4, it's root 2 over 2, or 1 over root 2. Tan pi over 3. Tan pi over 3, by the way, means this is pi over 6. That's pi over 3. So tan, opposite over adjacent. So that will be root 3. Cosecant, it's opposite of sine. So sine 30, it's 1/2. So reciprocal, it's 2. If we want to add this one in simplified form, the common denominator will be 2. So that will be root 2 minus, if we multiply here by 2 and 2, it will be 2 root 3. And that will be plus 4. Now, we have now two angles, 210 and 330. So 210, as we just said, it's in quadrant number 3, and the reference angle, it's 210 minus 180 will give me the reference angle, which is 30. Okay, and 330, again, STC will say if you want sine 210, it's the negative of sine 30. 330, it's in quadrant number 4, 330, and the reference is 360 minus 330, which is 30 again. So STC will say you have cosine 330 will be the same as cosine 30 because cosine is positive in quadrant number 4, but tan 330, it's the negative of tan 30. Then we go and see sine 210 minus cosine 330 times tan 330. That is equivalent to say sine, it's the negative of sine 30. Cosine, it's the same as cosine 30 because quadrant number 4 times tan, it's the negative of tan 30. So negative by negative will be positive. So that is cosine 30 times tan 30 degrees. I need the famous triangle. This is 30, that's 60 to 1 square root of 3. So sine 30 is 1/2, cosine 30 root 3 over 2, tan 30 opposite over adjacent, which is root 3. So you will get here minus 1/2 plus 3 over 2, which is 2 over 2, which is equal to 1. Okay. So again, sine 30 is 1/2, 1 over 2, cosine 30 square root 3 over 2, tan 30, it's opposite. Sorry, tan 30, it's opposite over adjacent, so I have done a mistake here. Tan 30, it's the opposite, which is 1 over root 3. So that's root 3 over 2, so that's 1 over root 3, and that will be minus 1/2 plus 1/2, which is 0. Tan is opposite, which is 1 over hypotenuse. Opposite over adjacent. Now, we have now 3 angles. We have to find each one of them in which quadrant. This is the first. That's the second. That's the third. These are part of the solution. So you must draw it in the midterm exam. 225, it's in quadrant number 3. That is 225. Reference angle, what is it? 45. How did we get it? It's 225 minus 180, which is 45. That is the reference angle. Second one, I have 240. Again, it's in quadrant number 3, 240. The reference angle is this one. What is it? It's 240 minus 180. That is 60. Third angle is 210. 210 again, it's in the third quadrant. So reference angle, it's 210 minus 180. That is equal to 30. So all of them, STC will say, if I have tan 225 plus sine 240 times cosine 210, that is equal to. Now, the first one, tan is positive in quadrant 3, tan 225, it's the same as tan 45, because tan is positive. Second one, we have sine is negative in quadrant number 3, so negative sine 60. Cosine is negative also, negative cosine to 10, it's 30. So I will have tan 45, negative times negative positive, sine 60, cosine 30. I need the two triangles. This is 30. That's 60 to 1 square root of 3. I have 45, 45, 1 square root of 2. Tan is 1. Sine 60, it's root 3 over 2. Cosine 30, it's again root 3 over 2. So I will get 1 plus 3 over 4. So over 4, it will be 4 over 4 plus 3 over 4 is 7 over 4. Again, we are repeating actually this idea because it's extremely important. As I said before, I don't change from one system to another system. Actually, it's easier in radian. So I have 3 angles. Let me show you how I will locate it easily. If I say 3 pi over 4, definitely it's smaller than 4 pi over 4, which is pi. So it's smaller than pi. And definitely 3 pi over 4 is more than 2 over 4, which is pi over 2. So our angle, it's here. It's 3 pi over 4, smaller, so more than pi over 2, smaller than pi. So what's the reference angle? Definitely it will be pi over 4. No need even to calculate, because we said it will be, if it is 4, it will be pi. Now, STC will say, if you have sine 3 pi over 4 will be positive of sine pi over 4, because sine in the second quadrant is positive. Second one, I have 5 pi over 6. Guys, 5 pi over 6, again, less than 6 pi over 6, which is pi. So this is 5 pi over 6. So the reference angle will be just pi over 6, because we said it will be 6. If it is 6 over 6, will be pi. So tan STC, tan 5 pi over 6 is negative of tan pi over 6, because in quadrant number 2, negative of tan pi over 6. Now, 7 pi over 6, guys, 7 over 6 is more than 6 over 6, means more than pi. This is 7 pi over 6. So that has to be pi over 6. And tan STC means tan is positive. So tan 7 pi over 6, it's positive tan pi over 6. So dealing with radian is even easier. So sine 3 pi over 4 times tan 5 pi over 6 plus 2 tan 7 pi over 6 is equivalent to, say, we said sine 3 pi over 4, it's the same as sine pi over 4. We said tan 5 pi over 6, it's the negative of tan pi over 6, plus 2. Tan 7 pi over 6, it's the same as tan pi over 6. Tan is positive. Now we need to know the two famous triangles. As we said, 30 means pi over 6. 60 means pi over 3. That's 2. That's 1. That's square root of 3. pi over 4, pi over 4, 1 square root of 2. So sine pi over 4, we said it's root 2 over 2. Sine tan pi over 6. Pi over 6 tan is opposite over adjacent, so it will be minus 1 over root 3, or we could say root 3 over 3. Minus 1 over root 3 or root 3 over 3. Plus 2 tan pi over 6. Pi over 6. Tan pi over 6, it's 1 over root 3 again. So, oh, it's the same. So it's root 3 over 3. So I will have here minus root 6 over 6 plus 2 root 3 over 3. So that is common denominator is 6. 2 will be here, multiply by 2 here, multiply by 2. It will be 4 root 3 minus root 6. Now, we are repeating actually same questions because it's extremely important. As I said, it must come in the midterm exam. Now, quickly, we have 2 cosecant 7 pi over 4 times tan 4 pi over 3 plus cosine 11 pi over 6. As I said, 7 pi over 4. Where is 7 pi over 4? Look here, shabab. 7 pi over 4 is close to what? If this is one more, it will be 8 pi over 4, which is 2 pi. So 7 pi over 4, that's 7 pi over 4. The reference angle pi over 4, STC, will say cosecant 7 pi over 4. It's negative because only cosine is positive. Cosecant pi over 4. 4 pi over 3. Look here, shabab. 4 pi over 3 is close to what? If this is 3, it will be pi. So it's more than. This is 4 pi over 3. So reference will be pi over 3. And in the second, this is STC. So tan 4 pi over 3, it's the same as tan pi over 3 because in quadrant number 3, tan is positive. 11 pi over 6, close to what? 12 pi over 6. So it's quadrant 4 because this is 11 pi over 6. If we complete it by 1, it will be pi over 6. So STC will say cosine 11 pi over 6. It's the same as cosine pi over 6 because in quadrant number 4, cosine is positive. So I have cosecant is negative, so it is equal to negative of cosecant pi over 4. Tan is positive, means tan it's pi over 3. Cosine is positive, so plus cosine pi over 6. The famous triangles. This is pi over 6, that's pi over 3, 2, 1 square root of 3. So we said here root 2 over 2 cosecant, tan pi over 3, pi over 3, the tan is opposite over adjacent, so it will be root 3, that is root 3. Cosine pi over 6, cosine pi over 6 is root 3 over 2. So what we will get, let me erase this one now, we don't need it. So plus, we said here, oh, what's written? So that what is equal to over 2 minus 2 root 6. What's this? This is equal to over 2 minus 2 root 6 plus root 3 over 2. So that is basically, it's simply same denominator. So we will have that is equal to square root of 3 minus 2 square root of 6 over 2. The last question we had in this section, that's the last question, right? Okay. Sine squared of 5 pi over 4 plus cosine squared of 5 pi over 4, but that's identity, so that is equal to 1. This will end up our section of 5.3. Thank you for listening to this nice question, and it's important section actually. Now we have to stop recording.